This is section 9.3, sample spaces. Our objective today is to make and use sample spaces and use the counting principle. Let's start with vocabulary. A sample space is the collection of all possible outcomes in an experiment. So all the possible things that could happen. The counting principle says that suppose there are m ways of making one choice and n ways of making a second choice, then there are m times n ways to make the first choice followed by the second. So I feel like the example might clear that up a little. You have 5 shirts, 5 ways to make your shirt choice. 3 pairs of shorts, 3 ways to make your shorts choice. You can make 5 times 3 or 15 outputs. So we're going to make a table to find the sample space for rolling 2 number cubes colored red and blue. We're going to write the outcomes as ordered pairs. So number cubes, remember, are just dice. So if I have a 1 in the red and a 1 in the blue, I have the coordinates 1, 1. The second box would be 2, 1 because a 2 and then a 1. We have 3, 1, 4, 1, 5, 1, 6, 1. Now we have 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, and 6, 2. 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, and 6, 3. 1, 4. Whoops. What did I just do? Sorry. There we go. 2, 4. 2, 4. 3, 4. Not 93, 4. That was supposed to be a parenthesis. 3, 4. 4, 4. 5, 4. 6, 4. Then we have 1, 5. 2, 5. 3, 5. 4, 5. 5, 5. And 6, 5. And finally, for our last row, we have 1, 6. 2, 6. 3, 6. 4, 6. Whoops. There we go. 4, 6. 5, 6. And finally, 6, 6. So we want to know the probability of rolling at least 1 3. So if you think about this in your head, it kind of would make sense that there's a column of 3s and a row of 3s, and if each has 6 in it, that should be 12, right? Well, there's not 12 ways to get a 3. If we count all the boxes, I'm circling them here, you'll see that there are only 11. The probability of getting a 3 is 11 out of our total possible outcomes, which, judging by our table, we can tell is 36. The probability of getting at least 1 3 is 11/36. So a table is one of the ways that we list our sample space. So try this one. You're going to get the sample space for tossing 2 coins. Well, if you think about it, the first coin can be heads or tails, so that can go across the top. The second coin could be heads or tails. So we turn that into a table as neatly as we can here, and then we fill in the table. This first box is heads, heads, then we have tails, heads, heads, tails, and tails, tails. So the probability of getting 2 heads, if you look at our table, we have 1 box with 2 heads in it out of 4 total boxes. So 1/4. Now we are going to travel on a river. We have 2 choices of boats, a kayak or a rowboat. And you can go upstream on 3 different streams, to the north, northwest, and northeast. We're going to make our sample space using a tree diagram. So this is another common way to list our sample space. A tree diagram branches out kind of like a tree. So let's think of our first choice. Our first choice is kayak or rowboat. You can shorten those to K and R, makes it a little easier. Well, if I choose a kayak, I now have to make the choice between the three streams. So I have three branches coming off of it. I have north, northwest, and northeast. If I choose the rowboat, I have to make that same choice, north, northwest, or northeast. The last thing for our tree diagram is that each of these final things gets its own little branch where I just list what that choice is. So here I went kayak, then to north, so it's kayak north. Here I went kayak northwest, so it's kayak northwest. Kayak northeast, so I'm just listing what the final choice would be. We have rowboat north, rowboat northwest, and rowboat northeast. So we want to find the probability that I select a trip at random and the probability of a kayak going north. So if I look at my final options, I have one that is a kayak going north, and there are 6 total options, so my probability is 1/6. Now we're going to add a canoe as another choice of boats to my previous example. We're going to draw a new tree diagram to show the sample space, and then we're going to find the probability of selecting a canoe at random. So try this quickly on your own. Alright, to start off, I start off with a kayak, a rowboat, or a canoe. And now each of those gets 3 choices. North, northwest, or northeast. North, northwest, or northeast, and north, northwest, or northeast. List off my final choices: kayak north, kayak northwest, kayak northeast, rowboat north, rowboat northwest, rowboat northeast, canoe north, canoe northwest, and canoe northeast. Now we're looking for the probability that I choose a canoe. So look at my final options. 3 of those have a canoe in them. Out of a total of 9 options, now I simplify that, and it is 1/3. And now for a counting principle example. How many different sandwiches can you order when you choose 1 bread and 1 meat? So you'll see that there are 5 types of breads and 6 types of meats. The counting principle says that I just take that 5, my first choice, times my second choice. I have 30 different possible sandwiches that I could make. So manager at the deli counter decided to add chicken. How many different sandwiches are there now? Try this on your own. Alright, there are still 5 bread choices, but now there are 7 meat choices. So that makes the total up to 35 different sandwiches. Here's your assignment.